So we connected our flex sensor, got it to interact with our LED light. Now we're going to add two more components building on what we've already made. And we're going to continue to compile in our code as well. So what we're going to need for this section is we're going to need a bunch of jumper cables, some alligator clips, which you see here. And then we're going to need a 10K ohm resistor. And this will be for our potentiometer, our soft potentiometer. And then we're going to have this, which essentially is touch activated. And when we move it around like this, when we move our finger around or whatever, it will activate. We want it to activate this servo motor. So we want this to spin every time we touch this along this soft potentiometer. So okay. So what is a soft potentiometer? Well, let's just start off by asking, or at least answering, what is a potentiometer? It is a variable resistor, which means it controls the flow of electricity. And for, things like knobs, which this is trying to simulate basically, is the more that you turn it, the more that it allows electricity to flow through. We can kind of get into the ways in which it actually functions, which is 3 terminals, and on each end it has a resistance, and along with the middle slider. We're not going to get into that per se. For our purposes here, it's just maybe easier to understand, or easier for me to explain, to be quite honest, that it is a variable resistor, and it allows for more electricity to flow through depending on how much you twist it or turn a knob. And so for something like a knob, its angle on a circle becomes really important to how much electricity is being let in. And a servo motor is really interesting because they are motors that move in almost a complete circle, but it moves in very fine increments. So you can really code it to move in however detailed you'd like it to move. And inside servo motors there are also potentiometers, but we won't get into exactly how it works on the inside. For us, what we need to know is that servo motors are really useful because it turns on an axis that we can control to a really fine detail. What we want to accomplish in this tutorial is we want to be able to press this and move it along as if it was a dial. Move it, and the more that we move it up and around, it will move this around. So this soft potentiometer has 3 ports. The one with the arrow is going to be connected to ground. The one in the middle is going to be connected to our 10K ohm resistor, along with a connection to our analog port. It's a sensor and it receives a range of values, so we want it to go into our analog port. For this, we're going to connect it to A1, and then this last prong here, it's going to be connected to power. For the servo motor, if you look here on this ribbon, you've got a brown wire, an orange wire, and a yellow wire. Our brown wire is going to be connected to ground. Our orange wire is going to be connected to power. And then our yellow line is going to be connected to a digital pin. It's going to be connected to digital pin 9. And as you see, 9 has a tilde. So it'll be translating a range of of information. It'll translate essentially 0 to 5 volts into a range of information that will mimic analog. So it'll go, as we remember with digital, it'll go from 0 to 255. So that'll be the input for the servo. Okay, so let's get it wired and get started. Let's start off with our servo motor. I imagine that's probably going to be the easiest. So we're going to connect this side, connect our grounds together so that we can then use this side to connect to this row. We're going to connect our power together. So now we've got power going all the way down here and then coming down to this side. Same with the ground. All right, let's get started with our servo. Brown and blue to me feel like dark colors. Red and orange feel like similar red power worlds, and white can be our, it'll go directly into our pin number 9. Easy. And we'll put this up here. Okay, whoops. All right. Okay, connected to ground, connected to power, connected to our pin 9. Servo is good to go. Okay, now we're going to connect our soft potentiometer. And as we remember, we've got this arrow section that's going to be connected to our ground. The middle one is going to be connected to our analog pin A1, and then this last one is going to be connected to power. Okay. Again, I don't have corresponding colors. Well, this doesn't really have corresponding colors, but I'd like to keep things a little bit consistent when I'm wiring things. So it's like all the whites will be the ports, and all the reds are going to be your powers, and all of the blues are going to be our grounds. So for this, we're going to have our blues still be our ground. For this alligator clip, the red is still going to be our power. And then last but not least, green is going to be the thing that's going to be connected to our port. So one end of the alligator clip is clicking into our little ports, and the other one is clicking to jumper wires. Cool. Power section here. Power is just going to be directly connected to power, so we'll just go ahead and do that real quick. Get that out of the way. Then we're going to get our port information. Green is the one that's going to be connected to A1. I'm going to put it here. Okay, but before we even begin to connect it to our port, we're going to go ahead and ground it. We're going to put our resistor in between this section and we're going to connect it to ground. Okay, so the green again is connected to that is supposed to be in direct communication with our Arduino, but in between the potentiometer and the Arduino, we want to put a resistor. So we put the resistor in between. Oh my goodness, we've put the resistor in between our Arduino and our connection to the board. And then last but not least is our ground. So we'll put that right over here. Okay, so now we're done wiring. We got everything up and together. Okay, so now let's make our way over to the Arduino IDE. We're going to pull it up however it is that you use it, and we're going to continue to add to our LED and flex sensor code. We're just going to continue to add, so we get used to adding multiple components into a code. So we're going to add our servos and our soft potentiometer. To start, we have to add a library for the servo motor, and we're going to do this at the very top. And before we even begin our setup or our loop, Arduino needs to download all of the things that come in with this library, so that it can recall certain functions that it's being asked to do. So we're going to include the servo library by adding hashtag include and servo.h. Okay, next we're going to create our servo object to control our servo. Okay, and then after we do that, we've got our constants here, right? We're still dealing with the very beginning of the page, so we're dealing with the things that need to be identified before anything even starts, like where things are and what things need to be pulled up. So we've got our constant integer LED pin number 3. We've got our constant integer of flex pin analog 0. That's where it's connected. So let's connect our potentiometer. So we're going to connect it at A1. So we're going to type const int pot pin equals A1. Great. All right. But we realize that we have two different analog sensors, both of which are getting value. And we need to store both of these values, and we need to store them as separate values. So we're going to go ahead and create another variable for our values to store. So we're going to call this one int value2, and it's going to save our secondary analog value. Okay, and then after we do that, we are going to we're just going to go ahead and get into our void setup. All right, so our void setup, we're going to have we have to attach our servo. We haven't identified where the servo is supposed to go, and we're going to put this in setup. We didn't put this at the very top. We're going to put this in setup, and this is unique to servos. So we're going to type in this function, myServo.attach, and we're going to attach it to our pin number 9, our digital pin 9. Okay, keep the rest the same, our pin mode and our serial. And then we're going to make our way to void loop, make sure we've got all of our appropriate endings to our sentences with our semicolons, and our curly brackets are both have been opened and have been closed. Okay, void loop, open curly bracket. Great. So we've got to set up our servo situation. So we have to get our value, and we need to tell Arduino to consistently loop and read the potentiometer to get the value of us touching it. So we're going to go ahead and call our value 2, and we're going to make sure that Arduino knows that value 2 is correlated or is equal to reading the information that's coming from our potentiometer. And then we also have to map it, right? We have to map it to so that it can be translated in a language that a servo can understand. And servos speak languages of degrees, 0 to 360. Well, actually a little bit less than 360, but we're going to just use 0 to 180 degrees for this one. And so we're going to map, we're going to use value 2 equals to map, and then bracket value 2 and we're going to map that information from 0 to 1023, which is the analog, currents, 0 is equal to 0 volts, and 1023 is equal to 5 volts. So this is a language that the potentiometer speaks, and we're going to map it to 0 to 180, which is the language of servo. Okay, and then next line is we're going to write it to the servo. So we're going to use the function myServo.write, and we're going to write the value that has just been received from the potentiometer, and we're going to delay for 15 seconds. And then actually what we're going to also do is we're going to print this value. So before we put in delay, we want to be able to see what information is coming. So we want to be able to track it. So we want to put it in our serial monitor. Before we do that, actually, we should probably name it something. Serial print, a serial.print, and then in brackets, we're going to put pot in quotation marks, and in the next line, we're going to do serial.print in a whole new line, our value 2. So we know every time it says pot, right below it will be the information from our potentiometer. Okay, great. And then we're going to delay that at 15. So 15 milliseconds. So it'll be quick. And then the rest of it will stay the same. So we're going to have our value of, we're going to have everything else from the flex pin and the serial print. What we'll include, though, is we're going to create a new line for our analog read flex pin, so that before it reads that information, maybe we should call that one flex. So on the serial monitor, you'll see flex and a number, and then you'll see pot and then a number. Okay, we'll upload it. Okay, we're going to pull up our serial monitor. Oh, cool. So we got pot 0, flex 539. Pot 0, flex 539. Cool. All we see is pot and flex and pot. Okay, we're going to move this to make sure this still kind of works. We see on our serial monitor that it is indeed moving. And then we're going to touch this and see that it moves. Ha! It's very sensitive. And we can see here on our serial monitor that it is indeed moving, that we are getting information. It's moving really fast, so it's kind of hard to see exactly. We'll directly get it to it. Love. Okay, that's it. We did it.